sections on trigonometry. In the first session, we generalized trigonometric ratios. Second session, we looked at reducing huge angles to their nearest or their best acute angles. Conversion of trigonometric ratios into their nearest acute angle ratios, right? Based on the parity of n. I told you if I had a trigonometric ratio whose angle was n into 90 degrees plus theta, then how you could reduce it to simply theta based on whether n was even or n was odd and the quadrant in which this angle n into 90 degrees plus theta would lie. Now, we also arrived at 4 basic results. If you recall, one result was, or rather 6 basic results, starting from sine of a plus b, which I told you just assume this for the time being. We'll come back to it when the time is right. I said sine of a plus b is like a sine a cos b plus sine b cos a. Alright. Based on this, we replaced b by minus b and we arrived at sine of a minus b as sine a cos b minus sine b cos a. And then cos of a plus b was like or cos a cos b minus sine a sine b. Also cos of a minus b as cos a cos b plus sine a sine b. Similarly, the corresponding tan of a plus b as tan a plus tan b by 1 minus tan a tan b. Same thing with tan of a minus b as tan a minus tan b divided by 1 plus tan a tan b. So you remember this result, right? Now, this bunch of results would act as a backbone for more results. So the session today would be like flurry of results, hosts of results, and that's an initial turbulent phase in trigonometry, but once you groove these results in your head, it's there in your head once and for all times, but then some special effort would have to be called upon so that these results are available from the top of your cranium whenever you need. Now, let me give you some results. Starting from these results, see, if I had like a sine of a plus b as sine a cos b plus sine b cos a and sine of a minus b as sine a cos b minus sine b cos a. Okay. If I add these two, I end up getting 2 sine a cos b. That's the right hand side. Right? These two get added up. This gets cancelled with this. 2 sine a cos b as sine of a plus b plus sine of a minus b. The result again that you need to remember here is conversion of sine a cos b. This is a product of sine and cosine, a sine and a cosine, product of a sine and a cosine, and that's equal to half of sine a plus b plus sine a minus b. Half of sine a plus b. So this is one more result, right? Conversion of a product into a sum. Sine a cos b is half of sine a plus b plus sine a minus b. Alright. Now, cos of a plus b, which means, if you had, like, let's say, a sine 30 degrees into cos 15 degrees, for example. So this is like a sine a cos b, and this product you want to translate into a sum. What would you do? This would be half of sine a plus b, that is sine of 45, plus sine of a minus b, that is sine 15 degrees. Right? Suppose you had like a sine 45 into cos. So that's going to be half of sine a plus b. Sine of a plus b is sine of 105 degrees plus sine of a minus b, which is minus 15 degrees. Right? But sine minus theta is minus sine theta. So this is like a half of sine 105 degrees minus sine 15 degrees, etc. Alright, so that's how you convert a sine cos into a sum, a product sine cos into a sum. Sine a cos b is half of sine a plus b plus sine a minus b, right? Let's see first of the series. Now, the next one. Cos of a plus b is like cos a cos b minus sine a sine b. Cos of a plus b is like a cos a cos b minus sine a sine b, and cos of a minus b we know is like a cos a cos b plus sine a sine b. Alright? Cos of a minus b is like a cos a cos b plus sine a sine b. Now, if I add these two, then I get from the right hand side 2 cos a cos b, and that's going to be equal to cos a plus b plus cos a minus b. Which means the second result available to us, cos a cos b, and that's equal to half of cos of a plus b plus cos a minus b. Right. So cos a cos b is half of cos a plus b plus cos a minus b. That's the next of the series. Cos a cos b is half of cos a plus b plus cos a minus b. So which means, let's say, you had a cos 30 degrees into cos 60 degrees, suppose. So that's cos a cos b, and you want to convert it into a sum. What would you do? Half of cos a plus b plus cos a minus b. So half of cos a plus b 90 degrees minus cos a minus b, which is cos of. Now in this case, realize that cos of a minus b is the same as cos of b minus a. Why? Cos minus theta is the same as cos theta. So cos of 30 plus 60, cos of a plus b minus cos 30 minus 60 or 60 minus 30 will be the same thing. So then cos 30 degrees. Right? So cos a cos b is half of cos a plus b plus cos a minus b. In this case, it does not matter whether you call this a and this b or you call this a and this b, because this is not going to get altered. And this cos of a minus b is the same as cos of b minus a. Why? Because cos minus theta is the same as cos theta. Alright, right? So cos a cos b is half of cos a plus b plus cos a minus b. So you could have called this a and this b and you couldn't care less. It does not matter, right? So that's the next member of the family. And then let me do this minus this. See, let me call this, let's say this was 1, this was 2, this was 3, this was 4. Alright. Let me do like a 4 minus 3. So cos of a minus b minus cos of a plus b, and that's going to be 2 sin a sin b, 2 sin a sin b on the right hand side. So then 2 sin a sin b, that turns out to be equal to cos of a minus b minus cos a plus b. Which means sin a sin b is half of cos A minus B minus cos A plus B. Right? That's another product into a sum. That's another product into a sum. Sin A sin B is half of cos A minus B minus cos A plus B. So then, for example, you have sin 40 degrees into sin 70 degrees. So this is a product, sin A sin B, and you want to convert it into a sum. So sin A sin B is half of cos A minus B minus cos A plus B. Cos A minus B minus cos A plus B, right? Sin A sin B is half of cos A minus B. Cos this minus this or cos this minus this is the same. So cos of A minus B or cos of B minus A, which is this, minus cos A plus B, which is 110 degrees. Sin A sin B is half of cos A minus B minus cos A plus B. Alright, sin A sin B, half cos A minus B minus cos A plus B. That's another result. So, these are three pertinent results. Result 1, result 2 and result 3 on conversion of product into a sum. This was conversion of a product into a sum. Conversion of a product into a sum. Got me? Yeah.
So that is sin 40 degrees. So how is so cos and sin are the same. I mean the angles are same. Cos and sin 70 degrees is cos 70 degrees.
Sorry?
We do sin 70 degree minus sin 40 degree. 70 minus 40 is cos 70. So that is sin. This is cos. So are we going to?
That's a result. Sin A sin B is half cos A minus B minus cos A plus B. I mean, I don't know if this is what you're wanting to say. We have a product in sine and we have a sum in cosine. Is that your question? No, but that's fine. That's the result. I mean, you wanted this product in terms of sine only. Is that your question? Well, you could have converted this into a sine because you could have written this as sine 60. Sine.
So aren't we going to convert it when we write it as cos?
This one you want to convert into sine?
No, aren't we going to convert it before we write it in cos?
No. This is the formula. Sin A sin B is half of cos A minus B minus cos A plus B. This is just the result. This is what you got to do. And now the conversion of this into sine is what you are implying. Now prior to this, no, why would you want to? The result is in terms of cosine. Why would you want to convert it into sine at all if not required? I mean, sin A sin B is half of cos A minus B minus cos A plus B. You wanted to do a conversion into what?
Into actually, it is complementary sin is plus.
Right. So
are we gonna 90 minus 40 degree, which will be cos 50 degree, and
then it would have been like a cos kind of a thing. You could have done that also. But if I have a sin A sin B, why would I want to convert this into cosine? Why would you want to do that? You could have done that. I mean, there is no loss of generality in doing that, which means, you could have written this as cos of 50 degrees into cos of 20 degrees and then applied a cos A cos B formula, half of cos A plus B plus cos A minus B. But that's not required. I mean, if in a situation it warrants that, we'll do that. But right now, I'm just wanting you to get acclimatized to these results. I mean, if in a problem, if we require that conversion, we'll do that. But if it's not required, why would you do that? Right now I just want you to understand how to convert a product of sine into a sum. How to convert a sine cos into a sum. How to convert a cos into a sum. All these products, sine cos, cos, sine. Three kinds of products are possible, right? There is a sine cos, there is a cos, and there is a sine. These three kinds of products are available. And we sometimes would like to look at the prospect of converting these products into sums. That's all. Right? So now, even before I add more results, I want you to remember this result. Let's see how we could just spend a little while to put it in our heads. So the first result, like I said, was a sine cos product, sine A cos B. A sine A cos B, like I said, is half of sine A plus B plus sine A minus B. I want you to spend time trying to remember this result in the class itself. Sine A cos B is half of sine A plus B plus sine A minus B. Sine cos, half of sine A plus B plus sine A minus B. Then the next one was cos cos. Cos A cos B, that was half of cos A plus B plus cos A minus B. That's the next. And then the third member of the series of products would be sin A sin B, which would be half of cos A minus B minus cos A plus B. Sin A sin B is half of cos A minus B minus cos A plus B. Spend 10 minutes putting these results in the appropriate location in your heads. 10 minutes is what I'm going to give for you so that you could remember these results before I add more. I'll ask you these results at the end of 10 minutes. At the end of 10 minutes, these three results you must remember. Write down, remember. I don't mind giving you 15 minutes, but when you are done with these three results, then I'll add more results. Okay? So 10 to 15 minutes. If you like more time, I'll give you more time, but these three results to begin with, write, scribble, or whatever is convenient to you, you must remember these results first. Alright, like I told you, the initial stage of trigonometry is about putting all these results in perspective. And then we'll start applying these results. You'll realize that over a period of time, there would be spontaneity in, closing these results out. But in the initial stages, there would be some resistance. You would have to push it a little hard so that you can remember these results. So don't feel intimidated by this. It's going to augur well. Right now, right here, 10 minutes, 15 minutes. Remember these three results of conversion of products into sums. And then I'll give you a few more results. Alright? Okay. So, you have these three results on your tips, right? So, at any point of time, even while you are in deep slumber, somebody wakes you up and inquires one of these results, you would be able to spell it out, right? Yes or no? Now, this was like conversion of product into a sum. The next set of results would be like conversion of a sum into a product, or sum into a product. Now, realize that sine of A plus B, like I told you, is sine A cos B plus sine B cos A, and sine of A minus B is sine A cos B minus sine B cos A, right? Okay. When we added these two, we arrived at sine of A plus B plus sine of A minus B as 2 sine A cos B. 2 sine A cos B, right? Now, let's say A plus B is C. A plus B is C and A minus B is D. Let's say A plus B is C and A minus B is D. Now, I can solve for A and B from these two equations. If I add these two, I get A. If I add these two, I get 2A equal to C plus D, and therefore A equal to C plus D by 2. If I subtract, I get 2B equal to C minus D. this minus this. So 2b is c minus d, or b is c minus d divided by 2. Okay, so now we chose a plus b as c and a minus b as d. So you get like a sine c plus sine d. Why? Because a plus b was chosen as c and a minus b was chosen as d. And that's equal to twice sine a. A is like a c plus d by 2 and b is like a c minus d by 2. So you have yet another result. But this time, it's like conversion of a sum into a product. Sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. Sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. So this is a sum converted into a product. A sum sine c plus sine d converted into a product. 2 sine c plus d by 2 cos c minus d by 2. For example, sine 30 degrees plus sine 40 degrees, right? Sine c plus sine d, right? Which would be 2 sine c plus d by 2. That means 70 by 2. That is 35. 2 sine c plus d by 2 to cos c minus d by 2. Now, whether I take cos c minus d by 2 or I take cos d minus c by 2, it's going to mean the same, right? So, cos 30 minus 40 by 2 or 40 minus 30 by 2, it's going to be the same. So 40 minus 30 is 10 by 2, that is 5. So sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. Does it make sense? Clear? See, ideally if I had to apply this formula strictly, then I'll get 2 sine c plus d by 2 cos c minus d by 2. So 30 minus 40 minus 10 by 2, which is minus 5. But cos minus 5 is the same as cos 5. So this is the same as 2 sine 35 degrees into cos 5, because cos minus theta we figured is cos theta, right? So that's sine c plus sine d equals 2 sine c plus d by 2 cos c minus d by 2. Now, a baby of this result is when you replace d by minus d. Replace d by minus d in this result. Replace d by minus d in this result. So then, sine c plus sine minus d. We'll do that at the very end. So that's 2 sine c minus d by 2 cos c plus d by 2 on replacing d by minus d. This is what transpires, right? But sine minus d is minus sine d. Sine minus d is minus sine d. So you end up getting sine c minus sine d equals 2 sine c minus d by 2 cos c plus d by 2. Sine c minus sine d is 2 sine c minus d by 2 cos c plus d by 2. That's another member of this conversion of sum into a product. Sine c plus sine d, 2 sine c plus d by 2 cos c minus d by 2. Sine c minus sine d, 2 sine c minus d by 2 cos c plus d by 2. Make sense, right? Okay. Now, couple of more results on similar lines. Cos of a plus b is like cos a cos b minus sin a sin b. Right? And cos of a minus b is cos a cos b minus plus sin a sin b. That's cos of a minus b, cos a cos b plus sin a sin b. Now, when I add these two, I get like a cos of a plus b plus cos a minus b is 2 cos A cos B. Cos of A plus B plus cos of A minus B is 2 cos A cos B. Again, like before, I choose A plus B as C and A minus B as D, leading to A equal to C plus D by 2 and B equal to C minus D by 2. So cos C plus cos D, alright? Cos C plus cos D. Cos C, this is A plus B is C and A minus B is D. Cos C plus cos D is 2 cos A. A turns out to be then C plus D by 2 and B turns out to be C minus D by 2. So 2 cos C plus D by 2 cos C minus D by 2. Cos C plus cos D is like a 2 cos C plus D by 2 cos C minus D by 2. So if I have, let's say, a cos 15 degrees plus cos 8 degrees, for example. So this is like a cos C plus cos D. So that's going to be 2 cos C plus D by 2 cos C minus D by 2, right? 2 cos C plus D by 2 cos C minus D by 2. Cos C plus cos D, 2 cos C plus D by 2 cos C minus D by 2, which is another sum into a product. Another sum into a product. Yes or no? Okay. Now, if I subtract this minus this minus this, then I end up getting cos of A minus B minus cos A plus B. Cos of A minus B minus cos A plus B, that is this minus this, then turns out to be 2 sin A sin B, because these two terms go into oblivion, right? It's 2 sin A sin B. Cos of A minus B minus cos A plus B is 2 sin A sin B. Now, again, this is C, this is D. So we have like a cos D minus cos C, cos D minus cos C, this is D, this was C, is 2 sin A turned out to be C plus D by 2 and B turned out to be C minus D by 2. Right? Now, just to put it in a more formal form, I write a cos C minus cos D instead, right? When I write a cos C minus cos D, then that turns out to be equal to 2 sin, that is, I multiply both sides with a minus sign, right? That's how it gets converted into a cos C minus cos D, multiplying throughout by a minus sign, minus 2 sin C minus D by 2 sin C plus D by 2. Yes or no? Cos C minus cos D is minus 2 sin C minus D by 2 sin C plus D by 2. Now, to reckon that minus sin theta is what? Sine of minus theta. Minus sin theta is sine of minus theta. So sine of C minus D by 2 minus sine of C minus D by 2, right? Minus sine C minus D by 2 is going to be sine of D minus C by 2. Yes or no? Minus sine C minus D. This minus can pierce through the sine function and cause this to become D minus C by 2. So minus sine theta is sine minus theta. That's the application here. So this minus sine theta minus sine C minus D by 2 could be written as sine D minus C by 2. That will absorb the minus sign. So in our attempt to absorb the minus sign, we represent it as follows. Cos C minus cos D is 2 sine D minus C by 2 sine C plus D by 2. Cos C minus cos D is 2 sine D minus C by 2 sine C plus D by 2. That's another result. So, this set of 4 results on conversion of a sum into a product. Let me just list these 4 results out categorically for you. Can I wipe this off? Right? One more test. ठीक है, share that. I can share that. Already. So, the set of 4 results on conversion of a sum into a product, right? So, conversion of a sum into a product. Conversion of a sum into a product, which is like first result sin C plus sin D, like I mentioned, is 2 sin C plus D by 2 cos C minus D by 2, right? 2 sin C plus D by 2 cos C minus D by 2. That's result 1. And then we enabled a small change here. We replaced D by minus D and we arrived at the second member of this family, sin C minus sin D is 2 sin C minus D by 2 cos C plus D by 2. See, second result, sin C minus sin D is 2 sin C minus D by 2 cos C plus D by 2. And then a cos C plus cos D is like 2 cos C plus D by 2 cos C minus D by 2. That's the third result. And the fourth result is like a cos C minus cos D is 2 sin D minus C by 2 sin C plus D by 2. So if we had a cos C minus cos D, then it's going to be 2 sin this minus this by 2 sin this plus this by 2. That's the fourth result. Conversion of a sum into a product. Right? Now, so first of all, convert the following product into sums and sums into products. Just to get hands-on with the results. Sin 30 cos 16 convert into a sum. Cos 14 cos 8 convert into a sum. Sin 10 sin 19 convert into a sum. Convert these sums into product. Convert these products into sums. And sin 30 plus sin 15 sin 30 minus sin 10 cos 25 plus cos 15 cos 55 minus cos 10. So convert these products into sum, convert these sums into products. Now, after you've done this bunch of results you remember, I want you to remember these results also. So I'll come in another some time. By that time you should have done both sets of problems and you should remember sin C plus sin D, 2 sin C plus D by 2 cos C minus D by 2, sin C minus sin D, 2 sin C minus D by 2 cos C plus D by 2, cos C minus cos D, 2 sin D minus C by 2 sin C plus D by 2, cos C plus cos D, 2 cos C plus D by 2 cos C minus D by 2. You must remember those 4 results in addition to the earlier 3 results and you must have solved these. Spend some time on this time. So by this time you've figured out sin A cos B, half sin A plus B plus sin A minus B. This is going to be half of sin 46 minus plus sin A minus B, 14, right? This is cos A cos B, which is half of cos A plus B plus cos A minus B, right? This is sin A sin B, which is half of cos A minus B, which is cos A minus B is the same as cos B minus A. So cos minus 9, which is the same as cos 9, half of cos A minus B minus cos A plus B. Sin A sin B, half cos A minus B, which is the same as cos B minus B minus cos A plus B. So your answer tallies, right? Okay, now this one. Sin C plus sin D, which is 2 sin C plus D by 2 cos C minus D by 2, right? And then sin C minus sin D, 2 sin C minus D by 2 cos C plus D by 2. Two cos C plus D by 2. 2 sin C minus D by 2 cos C plus D by 2. Right? Cos C plus cos D, 2 cos C plus D by 2 cos C minus D by 2. So 2 cos C plus D by 2 cos C minus D by 2. Right? Cos C minus cos D, 2 sin D minus C by 2 sin C plus D by 2. 2 sin D minus C by 2 sin C plus D by 2. Right? Sin C plus sin D, 2 sin C plus D by 2 cos C minus D by 2. Sin C minus sin D, 2 sin C minus D by 2 cos C plus D by 2. Cos C plus cos D, 2 cos C plus D by 2 cos C minus D by 2. Cos C minus cos D, 2 sin D minus C by 2 sin C plus D by 2, right? So these are 4 more results involving conversion of sum into a product. Alright? So 7 more results added to our collection of results, right? Now some more. Although you realize down the line that we started with one apex result, sin of A plus B, and everything came out of that one result. Everything, sin A minus B, and then cos A plus B, and then cos A minus B, and then product into a sum, and sum into a product, and so on and so forth, right? Now, some results that are related to what's called multiple angles. Multiple angles. Again, start with a sine of A plus B, which is like a sine A cos B plus sine B cos A. Sine A cos B plus sine B cos A. Now, in this result, put A equal to B equal to theta, let's say. Put A equal to B equal to theta in this result. So, you end up getting sine 2 theta as sine theta cos theta plus sine theta cos theta. Sine theta cos theta plus sine theta cos theta. So, that makes it 2 sin theta cos theta. That makes it 2 sin theta cos theta, right? So I end up getting sin 2 theta as 2 sin theta cos theta. Sin 2 theta as 2 sin theta cos theta, right? So for example, if I have to write sin 80 degrees in terms of 40 degrees. So what we do is we write this as sin 2 into 40 degrees, sin 2 theta therefore, sin 2 theta therefore, and that's going to be 2 sin theta cos, sin 2 theta is 2 sin theta cos theta, right? So that's one result on multiple angles. Sin 2 theta is 2 sin theta cos theta. Can I wipe this off? Now, cos of A plus B. Cos of A plus B is cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. Put A equal to B equal to theta. So you get like a cos 2 theta on the left hand side, and that's equal to cos theta into cos theta minus sin theta into sin theta. How about this? Putting A equal to B equal to theta. Cos 2 theta is cos theta into cos theta minus sin theta into sin theta. That makes it cos square theta minus sin square theta. So cos 2 theta is cos square theta minus sin square theta. Now, the other form in which it could be written, there are various forms in which this result is written. You can either write it as cos square theta minus sin square theta, or this result could be explicitly written in terms of cos theta. How? I could write this as cos square theta minus 1 minus cos square theta, and that makes it 2 cos square theta minus 1. That makes it 2 cos square theta minus 1. That's the other form of this result. Cos 2 theta could also be written as 2 cos square theta minus 1. Right? We could also have written it entirely and explicitly in terms of sin theta. How? I could have written this cos square theta as 1 minus sin square theta. This sin cos square theta could have been written as 1 minus sin square theta. So then, cos 2 theta, starting from here, writing this as 1 minus sin square theta So that makes it 1 minus 2 sine square theta. 1 minus 2 sine square theta. Cos 2 theta as 1 minus 2 sine square theta. Cos 2 theta as 1 minus 2 sine square theta. So three forms of this result. Three forms of this result. Can I just wipe this out? One form of this result is cos 2 theta is cos square theta minus sine square theta. That's one form of this result, right? The other form of this result is cos 2 theta is 2 cos square theta minus 1. And the third form is cos 2 theta is 1 minus 2 sine square. All these three forms you should remember right away. Cos 2 theta is cos square theta minus sine square theta. Cos 2 theta is 2 cos square theta minus 1 and is 1 minus 2 sine square theta. Sometimes you may also want to write cos square theta as half of 1 plus cos 2 theta. See, if you transpose this 1 on this side, what is it that you get? You get 2 cos square theta is 1 plus cos 2 theta, right? If you transpose this 1 on this side, then you get 2 cos square theta as 1 plus cos 2 theta, or cos square theta as half of 1 plus cos 2 theta. That's another form in which you want to remember. A cos square something is half of 1 plus cos twice of that thing. 1 plus cos twice of that thing. For example, cos square 30 degrees. Cos square 30 degrees can be written as half of 1 plus cos 60 degrees. 1 plus cos 2 theta. Cos square of something is half of 1 plus cos twice that thing. Twice that thing. Right? That's the other form in which you want to remember this result. Similarly, if you transpose this here, you get 2 sine square theta is 1 minus cos 2 theta. 2 sine square theta is 1 minus cos 2 theta. So I end up getting sine square theta as half of 1 minus cos 2 theta. It's half of 1 minus cos 2 theta. That's the other form in which I want you to remember this result. So then, the mother form cos 2 theta is cos square theta minus sine square theta. cos 2 theta is 2 cos square theta minus 1 or 1 minus 2 sin square theta, and then cos square theta half of 1 plus cos 2 theta, sin square theta half of 1 minus cos 2 theta, right? So in verbose, the way you want to mentally summarize this is cos of a certain angle. This is cos of a certain angle is cos square of half that angle minus sin square half that angle, isn't it? This angle is half of this angle. So cos of a certain angle, right, is cos square of twice that angle minus sin square of twice that angle. That's how you want to remember this, right? Cos of a certain angle is cos square twice that angle minus sin square twice that angle. I'm sorry. Yeah. Cos of, I'm so sorry. Half. I'm so sorry. Cos of a certain angle is cos square half that angle minus sin square half that angle. Yes or no? Cos of a certain angle is cos square half that angle minus sin square half that angle. That's how you must remember it. Cos of a certain angle is cos square of half that angle minus sin square of half the angle that you encountered. Got me? Similarly, cos of a certain angle is twice cos square half that angle minus 1 and is also 1 minus twice sin square half that angle. Alright, this is how you may want to remember this. Cos of a certain angle is cos square half that angle minus sin square half that angle, or is equal to twice cos square half that angle minus 1 or 1 minus twice sin square half that angle, right? So cos 2 theta, cos square theta minus sin square theta, cos 2 theta, 2 cos square theta minus 1, cos 2 theta, 1 minus 2 sin square theta. Got me? Now, again, if you divide this by this, you arrive at another important result. If you divide this by this, sin square theta by cos square theta would give me tan square theta, right? Tan square theta. And that's 1 minus cos 2 theta divided by 1 plus cos 2 theta. So 1 minus cosine of a certain angle divided by 1 plus cosine of a certain angle is tan square of half that angle, right? 1 minus cosine of a certain angle divided by 1 plus cosine of a certain angle is tan square half that angle. Cos 2 theta, cos square theta minus sin square theta, 2 cos square theta minus 1, 1 minus 2 sin square theta, cos square of a certain angle, half of 1 plus cos, twice that angle, sin square of a certain angle, half of 1 minus cos, twice that angle, right? These are some multiple angle results on cos and sin. Similarly, look at tan of a plus b is tan a plus tan b by 1 minus tan a tan b. Tan of a plus b is tan a plus tan b by 1 minus tan a tan b. So if I put a equal to b equal to theta, a equal to b equal to theta in this result, I end up getting tan 2 theta on the left hand side, tan 2 theta, and this is tan theta plus tan theta, which is 2 tan theta, divided by 1 minus tan theta into tan theta. That makes it tan square theta. So that's another important result. Tan 2 theta is 2 tan theta by 1 minus tan square theta. Tan 2 theta is 2 tan theta by 1 minus tan square theta. Right? So we have sin 2 theta is 2 sin theta cos theta. Cos 2 theta is cos square theta minus sin square theta, or 2 cos square theta minus 1, or 1 minus 2 sine square theta. Tan 2 theta is 2 tan theta by 1 minus tan square theta. Right? You got me? Now, some more, and then I'll give you some time to get more familiar with these results. Now, suppose I had like a sine 3 theta. I want to derive a result for sine 3 theta. Realize that I could write this as sine of theta plus 2 theta, which is sine of a plus b. But the sine of a plus b is sine a cos b plus sine b cos a. This is equal to sine a cos b plus sine b cos a. Sine a cos b plus sine b cos a. Right? Now this is sine theta. I want to write it entirely in terms of sine. Now did I tell you that cos 2 theta written in terms of sine is like 1 minus 2 sine square theta is like a 1 minus 2 sine square theta. So cos 2 theta is 1 minus 2 sine square theta. Right? And I mentioned that sine 2 theta is 2 sine theta cos theta. Sine 2 theta is 2 sine theta cos theta. So I write this sine 2 theta as 2 sine theta cos theta. And then there was a cos theta sitting already. Sine 2 theta is 2 sine theta cos theta into cos theta, which is there. Now, this is like sine theta into 1 minus 2 sine square theta plus. Now cos theta into cos theta is cos square theta, but cos square theta is 1 minus sine square theta, right? So plus 2 sine theta into 1 minus sine square theta. Right? Now this is sine theta into 1 plus 2 sine theta into 1. That makes it 3 sine theta, right? If you collect the terms, sine theta into 1 sine theta plus 2 sine theta, that makes it 3 sine theta minus 2 sine cube theta from here and minus 2 sine cube theta from here. Yes or no? This 2 sine theta into minus sine square theta minus 2 sine cube theta, and this sine theta into minus 2 sine square theta is minus 2 sine cube theta. So minus 4 sine cube theta, right? So sine 3 theta is 3 sine theta minus 4 sine cube theta. Sine 3 theta is 3 sine theta minus 4 sine cube theta. That's another result. Sine of thrice of a certain angle is 3 sine that angle minus 4 sine cube that angle. Or the other way to put it in verbose is sine of a certain angle is 3 sine 1/3 that angle. See, this is a certain angle, then this would be 1/3 of that angle. Sine of a certain angle is 3 sine 1/3 of that angle minus 4 sine cube 1/3 of that angle. Right? So sine of a certain angle, 3 sine 1/3 that angle minus 4 sine cube 1/3 that angle. Got it? So that makes it sine 3 theta is 3 sine theta minus 4 sine cube theta. Alright. So then the next result in the pipeline should be cos 3 theta. Cos 3 theta. Which is like cos theta plus 2 theta. I could write this as cos of theta plus 2 theta, cos of a plus b. That makes it cos a cos b minus sin a sin b. Minus sin a sin b. Cos a cos b minus sin a sin b. Now I want to express the whole thing explicitly in terms of cos 3 theta. I would prefer to write if possible entirely in terms of cos, all cos functions, right? So cos 2 theta, like I told you, is 2 cos square theta minus 1. 2 cos square theta minus 1. So I could write this cos 2 theta as 2 cos square theta minus 1. Cos theta into 2 cos square theta minus 1. Right? And like I said, sine 2 theta is 2 sine theta cos theta. That's another result. Sine 2 theta is 2 sine theta cos theta. So then I write this minus sine theta into this sine 2 theta written as 2 sine theta cos theta. 2 sine theta cos theta. Right? Which is cos theta into 2 cos square theta minus 1. And then this sine theta into sine theta is sine square theta, which could be written as 1 minus cos square theta, because my objective is to write the right hand side entirely in terms of cos, right? So minus sine square theta, which is 1 minus cos square theta into cos theta. This sine square theta written as 1 minus cos square theta into cos theta. Now, which makes it, see, cos theta into 2 cos square theta is 2 cos cube theta. 2 cos cube theta. And then plus cos square theta into cos theta into 2 is 2 cos cube theta. Again, do you realize that? Minus minus plus 2 cos square theta into cos theta, that's 2 cos cube theta. And then there is a 2 cos cube theta coming from here. That makes it 4 cos cube theta. Or minus. Okay, minus cos theta from here. And then minus 2 into cos theta. So minus 2 into cos theta minus cos theta, that is minus 3 cos theta. Minus 3 cos theta. So cos 3 theta as 4 cos cube theta minus 3 cos theta. Cos 3 theta is 4 cos cube theta minus 3 cos theta. So we have a result for cos 3 theta now. We derived a result for sin 3 theta. So the next one should be tan 3 theta. Tan 3 theta. Now, tan 3 theta should be written as tan theta plus 2 theta, which is tan of a plus b, which is tan of a plus b, which is tan a plus tan b divided by 1 minus tan a tan b. Tan a plus tan b divided by 1 minus tan a tan b. And the result that we've arrived at for tan 2 theta is 2 tan theta by 1 minus tan square theta. Right? 2 tan theta by 1 minus square theta is the result that we've arrived at. So replace this tan 2 theta by 2 tan theta by 1 minus tan square theta. So this is like tan theta plus 2 tan theta by 1 minus tan square theta, and then the whole thing divided by 1 minus tan theta into tan 2 theta, which is 2 tan theta by 1 minus tan square theta. Right? So now if I add and simplify, this is what I get. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. I want you to check on the algebra yourself. 3 tan theta by 1 minus 3 tan square theta, that's the result for tan 3 theta. Tan 3 theta is 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Another result. It's another result. Right? And one last result for the day. And then you have a task ahead of you. You have to get all these results in the right location, right? So this is a one-time effort. It pay off. Because even before we get started on problem solving in trigonometry, you have to be goddamn comfortable with all these results. Make sure you spend your time at home putting and assembling these results in place. Right? Get absolutely wild about it and be totally involved with this. While eating, while drinking, while sleeping, while talking, and while doing nothing, do this. Right? In fact, not just remembering the result, also keep scribbling on paper and derive these results independently the way. Right? So, for the next 1 or 2 days, just keep doing this again and again and again and again. Alright, till such time that you master these results to the core. Both the results, the final result, and how the result was derived. Alright? Because until then, problem solving in trigonometry will be futile. Now, realize that sine of a plus b into sine a minus b. Did I tell you that the result, sine x, sine y, sine a, sine b is like half of cos a minus b minus cos a plus b. That's the result, right? Sine of something into sine of something is cos of the difference minus cos of the sum. Sine of something into sine of something is half of cos difference minus half cos sum, right? Sine a, sine b, half cos a minus b minus cos a plus b. So this is like sine of something into sine of something, right? This is sine of x into sine of y, right? This is sine of x into sine of y. That's going to be half of cos x minus y. But cos of x minus y or y minus x is the same. In any case, cos of x minus y is cos of 2b, right? Cos of a plus b minus a minus b is 2b. Cos of x minus y minus cos x plus y. This plus this is 2a. Yes or no? Cos sine x sine y is half cos x minus y. X minus y is 2b minus cos x plus y, that is 2a. So that makes it half of. Now, the result for cos 2 theta in terms of cos is like 2 cos square, or in terms of sine is like 1 minus 2 sine square theta. Cos 2 theta is 1 minus 2 sine square theta. So cos 2b would be 1 minus 2 sine square b. Cos 2a would be 1 minus 2 sine square a. This one and this one would get cancelled. You'll have 2 sine square a minus 2 sine square b, and the 2 gets cancelled from the numerator and denominator, and that makes it sine square a minus sine square b. So we have like a sine a plus b into sine a minus b. Sine of a plus b into sine a minus b is like a sine square a minus sine square b. It's like a sine square a minus sine square b. Sine a plus b into sine a minus b is sine square a minus sine square b. So sine of 30 plus 15 into sine 30 minus 15. Sine of a plus b into sine of a minus b, that makes it sine square 30 minus sine square 15. Sine square a minus sine square b. Very important result. Very important result. Sine of a plus b into sine of a minus b is sine square a minus sine square b. One more result. Another result. Now, cos of a plus b into cos of a minus b. Now, realize that cos x cos y from the earlier set of results is cos of something into cos of something is half of cos x plus y plus cos x minus y. That's the result, right? Cos x cos y is half of cos x plus y plus cos x minus y. So cos x cos y. We have a cos x and a cos y. That makes it half of cos x plus y, that is 2a, plus cos x minus y, that is 2b. Cos of x plus y plus cos of x minus y, right? Cos x cos y, half cos x plus y, which is 2a, plus cos x minus y, that is 2b. Now, cos 2a can be written as 2 cos square a minus 1, and cos 2b in this case I would write as 1 minus 2 sine square b. I'll tell you why I would want to do that. Because when I add these two, I want the 1 to get cancelled. I don't want 1 to stick around, because if I had written it as 1 minus 2 cos square b, then on adding, there would have been a minus 2. And I don't want this 1 to stick around in the final result. Only out of aesthetic considerations, nothing else. It's ornamental that I want to do that. Right? So that this constant term does not stick on. Right? So now cos 2a plus cos 2b would be 2 cos square a minus 2 sine square b. Yes or no? So then this is half of, writing cos 2a plus cos 2b is 2 cos square a minus 2 sine square b. That makes it cos square a minus sine square b. So another result, which is cos of a plus b into cos a minus b, is cos square a minus sine square b. I want all of you to remember this result. Cos of a plus b into cos of a minus b is cos square a minus sine square b. And sine of a plus b into sine of a minus b turned out to be sine square a minus sine square b. Whereas cos of a plus b into cos of a minus b is cos square a minus. Right? So we have results relating to conversion of product into sum into products, multiple angles, cosine, sine, tan. And then two more results, cos of a plus b into cos of a minus b and sine of a plus b into sine of a minus b. So consolidate all these results and make sure you remember these results. Day in and day out, just keep scribbling on a piece of paper the derivation, the result. The next 1 or 2 days, you must spend just doing this and nothing else. Alright? Beginning of next session, I would ask these results, and any one of these results picked up from any one of the locations, you should be very prompt and spontaneous in responding. Alright? Trigonometry starts here, but gets very fascinating once you go past the boisterousness of a stormy bunch of results. You would really take jewels in it. It gets very fascinating, but then the first stage, the first step towards conquering the art and science of trigonometry would be to cluster these results in your head very methodically and very perfectly. Alright? So, this much for today. In the meantime, why don't you just quickly go through everything in another next 15, 20 minutes, half an hour, everything from the beginning till the end for the session today. And in the even, so spend, let's say, half an hour going through. If you have questions, I'll address your questions. Else, at the end of it, you can leave. Right? Thank you.